Hey everybody, Mr. Eberhardt here again. This time we're here to talk about the surface area of prisms. So our essential question is, how do I find surface area? Go ahead and pause and write that down, and then we can get started. So first off, our definition of surface area. Surface area is the sum of all the areas of all sides of a prism. So remember, sum means addition, so we're going to add together all the sides of a prism, and hopefully you remember from elementary school what a prism is. A prism, I'll show you a picture right here, for example, can be shown on the right here. One of the most common prisms that we see usually is a rectangular prism. You can see these are all made entirely of rectangles. So Kleenex boxes, boxes of cereals, things like that. We'll talk about triangular ones in a little bit. But you can see here, this is one rectangular prism, and each picture shows one of the sides shaded in. So a rectangular prism has 6 sides. Surface area is the sum of all of those shaded sides. Basically, it's how much wrapping paper it would take to wrap paper all around this rectangular prism. So let's see where we can, or how we can find that. This next slide here, please do not write what's on this page. You can certainly jot down notes if you want, but do not copy everything that I have here because it would be a lot to write, and the pictures are going to be kind of annoying to jot down. So I would just jot down what you think is important, what are the big takeaways from this slide, but don't copy it all 3 pictures because it would take a long time. So looking at this picture here, this is what we call a net. This is a net of a rectangular prisms, because if we took a rectangular prism, or think of it like a cereal box, and unfolded it all the corners and edges away, it would look like this. The top of the prism is up here, front, bottom, and back. So you can see all 6 sides that we saw on the last slide are represented here. So this is another different direction we could have written it, right? So we just kind of rotated our rectangular prism around. You can see some patterns here. If this is the front of the rectangular prism, this lines up basically like the front of the cereal box up there. Those 2 things align. Well, this front is the exact same size as the back, right? The front and back of a cereal box are the same. The same thing is true of the top of the box and the bottom of the box. So that'd be this side here, and then the other side that you can't quite see, so that side right there. And then, sorry, let me erase that really quick. The 2 sides, so I'll just call this side A and side B, are also the same. So we can use those properties to actually help us find the surface area, because now instead of finding the area of 6 rectangles, we only need to find the area of this rectangle, and this rectangle, because once we have all 3 of those, we can simply double it to include the top, side B, and the back. So we're going to practice that in just a second. All right, here's an example. You should draw the best picture you can of this, because this is the first example. You're responsible for being able to do this. So in this example, I say L for length. The length is 4 yards, so I'm just going to label our picture. I'm going to call this distance here length, so that's L, cursive L. Width is 2 yards, so I'm going to say this is my width right here. And then height, it says, is 5 yards, so H is right there. So I'm going to label them each. So we said length was 4, width was 2, and then height was 5. So we're going to use that pattern we talked about on the last slide to find our surface area. Let's focus first on the front and back of this rectangular prism. So I'm looking at this rectangle here, and then the back of it is with these dotted lines, sort of see-through right there. So those are the 2 rectangles that I'm trying to find the area of. Well, if you remember from our earlier lessons, the area of a rectangle is just its length times its width. So this distance here is 4, and then this distance here is the height of the prism, so that's 5. So the area of that front rectangle, so the area of the front is 4 times 5, which is 20. And as we talked about on the last slide, the front and back of this rectangular prism are equal. So if I know the front is 20, I know in total the front and back combined should be double that. 20 times 2 is 40, sorry, 40, and these are in yards squared. So the front and back combined is 40 square yards. Now let's do the same thing for the top and bottom of this box. The top is this rectangle here, and the bottom is this rectangle down here. So let's find the area of one of these. This bottom one here might be a little bit easier to read. Let me quick tidy this up. So on the bottom, if we've got this distance here again is 4. Now we're looking for this distance. Well, that's our width, which is 2. So that top and bottom rectangle are both 4 by 2, 4 yards by 2 yards. So that bottom rectangle is 4 times 2, which is 8 square yards. They're both the same though. Top and bottom are the same. So in total, the area of the top and bottom combined is 16 yards. And now let's do the last with left and right rectangles here. So let's change our color. We're looking at the last two rectangles that we haven't found the area of yet, which is this one and this one, which are the same. So this distance here, I'm going to look at this left rectangle. So the height is still 5, and this distance here is still 2. So that's a 5 by 2. So that's the left side. That's a 5 by 2 rectangle. So 5 times 2 is 10. And we've got 2 of them. So 10 times 2 is 20 yards squared. Well, we've successfully found all 6 sides together then. We've got the front and back are 40, the top and bottom are 16, and the left and right are 20 total. So now all we have to do is, for surface area, is add them all together. We've got to do 40 plus 16 plus 20, which should give us 76 square yards. All right, I know this is kind of a lot, people, but we're on our last example. So we're going to look at surface area of a triangle. Actually, it should be triangular prism. Triangular prism. Sorry about that. So we're going to look at the surface area this time, not of a rectangular prism, but of a triangular one. So again, do your best to draw a rough sketch of this picture as best you can. I know it's not going to be perfect, but that's okay. So here in our triangular prism, just like with the rectangular prism, there's not going to be some fancy formula that we use. We just have to break them down into smaller parts. So in a triangular prism, you've got 2 bases, and both bases are triangles. So I'm going to draw my 2 bases in blue here. All right, sorry about that again, guys. As I was saying, the 2 bases in this prism are triangles. So we got one triangle here, and we got one triangle there. Now, I know I'm calling them bases, even though they're not on the top and bottom. That's just fine, because all you have to do is think about tipping this over to look like this, and now you've got the triangle on the bottom. So we call them the bases because they're the triangular portions. So just remember that they're triangles and not rectangles, and you should be fine. So our 2 bases are both triangles. Hopefully you remember the area of a triangle, as I'm sure Mr. Campbell taught you well, is base times height over 2, or 1/2 times the base times the height. Either one is fine. I'm probably going to keep sticking with that one though. So let's find the area of one of these triangles. Let's do this front one right here. Let's find the area of that triangle. So the area equals base. The base of this triangle is 8. So we're going to do 8 times the height right here is 6. And we're going to divide by 2. So let's do that math really quick. We've got 8 times 6, which is 48. Getting ahead of myself. 48 divided by 2 then is 24. So that's one of the triangles. That's just the front. In order to find the area of the back one, all we'd have to do is double this. So combined, this would be 48, in this case, square centimeters. So there are our 2 triangular bases. Now let's look at rectangle side 1. It doesn't matter which rectangle you call 1, 2, and 3, because you're going to find all 3 anyway. So I'm going to call this one over here. Whoops, sorry about that. I'm going to call this one over here 1. So let's find the area of that. It's going to be rectangle 1. This distance here is 4, because it matches with that one there. And the height is 6. So area of that rectangle is 4 times 6, which is 24 centimeters squared. Side 2, I'll call this big rectangle on the top rectangle number 2. So we've got that side there is 10, and this side here is 4. So that would be area equals 10 times 4, which is 40. And last rectangle, which again, we only have one option left, is this bottom one down here. And that is an 8 by 4 rectangle. So area equals 8 times 4, which is 32 centimeters squared. Just like in our last example, to find our final answer for surface area, we just have to add them all together. 48 plus 24 plus 40 plus 32, and that gives us 144 centimeters